Okay. Nikolay. Nikolay is going to present Hyperledger Fabric. Thank you.
Thank you very much for introduction. So my name is Nikolay. I work for IBM in the Blockchain Garage here in Singapore. And the topic is Hyperledger Fabric version 1, which is the new version that is coming very, very, very soon. So before going... Is it okay? Yeah. Before going to version 1, just a quick recap why we decided that we are ready to move to the next version. So what we've learned from version 06, there are a number of limitations, and that's the current architecture of version 06. As you can see, there is an SDK that implements the client. There is a membership service, which is a kind of centralized service, and there is a peer in the network, which is doing lots of stuff. You see, it's quite busy. So the centralization of membership service is one weak thing, and then this peer is doing too many things at the same time. It's the throughput, the number of transactions that we can perform is quite limited. Now, the other considerations that, or other limitations that we found and we took into consideration for version 1, it's the privacy of transactions. Here, for example, there is a network of car manufacturers and lease companies. The car manufacturers are blue, lease companies are yellow, and there is a regulator in the center. So they want to perform a transaction, and let's say there is a Nissan who wants to sell the car to Lease Plus with 5% discount. In the current implementation, if all of them will be in the version 06, this transaction will be visible to all the validating peers running on all the data centers of all these companies. That's definitely we don't want to be possible. We don't want everybody to see what exactly was the discount that Nissan gives to Lease Plus. Then the vault state. Vault state in the current version 06 is a key value store implemented on top of RuxDB. And it is quite restrictive, as you can imagine, in terms of queries that you can perform, since it's a key value store. We wanted to have basically to have a pluggable key value store, a pluggable storage, and we want to perform an SQL-like queries in order to do more interesting analysis of the data. So this is the list of all things that we want to do. Reflect how the business is working in terms of endorsement, transaction endorsement policies, and making sure that the transaction goes only to the parties that's supposed to know that this transaction is happening and the details of this transaction. Scaling is another problem. Right now, it was limited because of the way how the consensus algorithm was implemented. Eliminate non-deterministic transactions where the vault states basically goes out of sync on some of the peers. Sometimes it happens in the current version 06. Enable pluggable data store and be able to upgrade the fabric and chain code, because right now, if you ever worked with 06, it's a huge headache if you want to update the chain code in the network archive production mode. And finally, remove the single point of failure, which everybody is pointing to, and that's membership service. So, the roadmap. So we are here in March, and this is the month where version 1.0 is supposed to be released. At the end of this month, actually. There's going to be a huge conference in Las Vegas next week, held by IBM, and we expect to have a number of announcements made there. Let's go into the architecture and architecture overview for version 1. Now, as you can see, architecture is changed. We have much more boxes here. The application SDK stays where it was and performs the same thing. The business logic for the application and the keys are key wallets with the private certificates of the users. The membership service becomes also the pluggable, and we can have a number of membership services now. So we remove this single point of failure. The peer can perform two different roles. It can be an endorser or a committer. Committer peer just commits the transaction. Endorser peer performs transaction validation. And we will look into this on the next couple of slides on how that exactly happened. But we actually we decoupled this from the peer, so they can perform different roles, and that's how we can scale. Another thing that we did in order to be able to perform transactions in parallel, we introduced this ordering service over here. So ordering service does only one thing. It takes all the transactions from the network, orders them, and then creates a block for that. So that makes it possible to do a transaction validation in parallel on different peers, and then they all send those transactions to ordering service in order to create a block. And this ordering service is also can be decentralized, so there can be a number of servers performing this particular role, and they all will be like choosing the leader every time they need to create a new block. Okay, so I will be skipping some of the slides because I have way too many of them, as usual with IBM. Let's have a look at how transaction is happening in the new version. First, we have a client, which is like outside of the network itself. And then we've got two types of the peers, like the bluish kind of E peer is the endorsement peer, and the gray peer is, we call it either like a P peer or committer peer. And we've got the ordering service, which is also represented like a network in the architecture. So first thing that client does, it sends the transaction proposal to either the nearest peers or the peer that he likes. The proposal includes the usual thing, like the function of the chain code that I want to trigger, as well as the input parameters. So I send in that, and the endorsement peer executes this transaction, creates the output, and then signs it and sends back to the client. Then client takes this thing along with the transaction proposal, and according to the policy, which is another new thing that we have in the new architecture, it sends this transaction proposal and the signature to other endorsement peers. So the policy is basically a configuration. It's like a business rule. It defines that we need to get an agreement from this, and this peer in order to perform a transaction, or it can be like one big peer, or like somebody like a regulator, somebody very important that needs to approve the transaction. So it's more like a business rule that defines who needs to approve a transaction before we define that it's valid. So client sends this transaction endorsement to other peers. They're supposed to approve it. They execute this transaction, validate that the output is correct, and then send back their transaction valid signatures. After that, client takes this transaction and sends to the ordering service. And then ordering service creates a block along with all the other transactions that it received during this particular time period, and then sends it, replicates to all the peers that are supposed to get it. So as you can see, the architecture becomes very decentralized. And finally, of course, they validate and then commit that into their vault state and create a new block in the blockchain. So as you can see, the architecture is very decentralized now. We can have a number of different endorsement peers, a number of committer peers, ordering service, etc. And it allows us to perform a number of transactions in parallel, which is quite nice. Now, we also move lots of logic to the client itself. It's not, it doesn't mean that client has to do all of this. It's good if it will do that. But again, with the configuration, we can say, is it going to be the client or the nearest peer who does all of this dance with transaction approval process according to the to the policy. Now, the endorsement policies are actually connected to the chain code. So when you deploy the chain code, the endorsement policy is something that goes along with the deployment itself. This is just the example. As you can see, the endorsement policy basically look like a business rule. We have the endorser set, like that's everybody in the network in this particular channel. I will talk about the channels on the next slide. And then we are saying that the new card transaction needs to be validated by the DVLA, which is, in our case, it's a regulator, and the Nissan as a manufacturer. So only they can validate, or we need to get the signature from both of them in order to create a new digital representation of a car in our vault state. Similar example from with the change ownership transaction, that it needs to be moved from the car manufacturer to the lease company, as well as needs to be approved by the regulator. So all of them needs to agree first, and that's what we define in the policy. There can be and/or statements as well, so that allows to create quite complicated rules in policies. Another important thing that we are going to have in the new version is channels. So you may think of a channel as a blockchain. So right now in version 06, we've got only one blockchain, or ARCA, one channel. With the new version, we can run parallel channels on the same network. Some of the peers can perform transactions on 2 or more channels. Some of them can perform transactions on only one channel, etc. So here in this example, E1 is on 2 channels at the same time, red and blue, and E0, and E1 is only on channel red. That means that E1 will never get any transaction from the blue channel. And that's how we can establish this privacy of transactions. The peers that are not supposed to get a transaction will never get it because they're not part of the channel at all. Ordering service. Ordering service, as I mentioned already, it just performs the ordering of transactions. It doesn't look into transaction, doesn't need to execute the transaction. It just takes it and then orders in the block, because the order is important since we're creating a hash for every block. There is a number of consensus algorithms that we use in the ordering service itself, because it itself creates like a small network. The first 2 are going to come with the first release. Solo is for development purposes, just one ordering server. Kafka, or Zookeeper, is going to be another one that basically it allows to tolerate just the crash faults or between faults. And it's going to be part of the first release. SBFT, to tolerate Byzantine faults, is going to come later, maybe like 1 point something version. It's currently under development. Okay, so in the new version, we can create the same architecture as we used to use in version 06. So this is an example, just one channel. Everybody, all the peers are executing the same chain codes. So exactly the same kind of behavior that we are getting here on this kind of architecture. Ordering service in the center, etc. In a multi-channel network, the picture will be a bit different. So we've got endorsement peers 0 and 3 on the red channel, and 2 and 1 on the blue channel, and they will never intersect. But at the same time, they can use the same ordering service. And as long as this ordering service doesn't see the transaction itself, it doesn't compromise the privacy, which is quite good. So we can reuse the same service for different channels without compromising the privacy, which I believe is just great. Pluggable vault state. We've got, remember I mentioned that currently we use RocksDB. With the new version out of the box, so we will get LevelDB. Again, it's a key value store, but then there will be an option to switch to the CouchDB, which is a NoSQL database with based on the JSON documents. that actually brings us lots of options to create complicated queries, rather than right now we are limited to either using a key or using a composite keys kind of thing. So imagine everything that comes to the data analysis and all this crazy stuff that our business people want to do with the data. And last but not least is the Fabric Composer. It's a kind of early version right now. It's not necessarily going to be, it's not part of the 1.0. The current version works with 0.6. But that's a kind of thing that, like a new tool that IBM contributes into the Hyperledger project. And it's meant to be, it's meant to simplify the development of the blockchain applications. Because right now you need to do a number of things. You need to create a chain code, you need to deploy it, you need to then create a client-side application with either Node.js or some other programming language. So lots of manual steps, and you need to keep everything in sync in terms of like which functions you implement on which side and how do they interact with each other. With the composer, we are supposed to get a number of tools that help us to develop things much faster. It's coming, starting from the command line utilities, the simple business-oriented language to design the data model and the transactions, web-based playground and web-based user interface. And let me, and let me show you a couple of examples. So that's the development playground, and this specific screen shows you the example of the, what is this? The asset creation. So we are, this tool is oriented on automating business processes mostly. So there are a number of concepts that are built into the, this business language that they use to create the participants of the network first. Like we define them as objects. And it's a Swagger-like language, scripting language. Then the assets that we're going to put into the vault state. Also, you can see quite simple, just the type of the property, and we can mark some of them optional, etc. And then the transactions, which are basically a definition of operations that we can do on our data model. And then finally, we can implement those transactions using the processors and in JavaScript. Because right now, as you probably remember, we can create chain code in Go language, in Java, and this is an option for develop the chain code in JavaScript, which is also quite cool because it's one of the most popular languages at the moment. Okay, so once we do all of this, the process, the development cycle would look like this. So we install the tool, we define the business network assets and transactions using this Swagger-like language. Then we implement the transaction processes, so basically the business logic within the transaction. Then we generate application and deploy it to the server. And then after that, we basically can generate the REST APIs using the loopback connector, and as well as Yeoman generator can generate us some simple Angular 2 code application. And we are good to, and that can be a good point to start. Link is down here. It's all open source. Just go download, learn it. It's currently an early stage, of course, but that's definitely something that is gonna evolve quite fast. It gets lots of traction at the moment. So with this, thank you very much, and I open for Q&A.
Thank you very much. We have about 5 minutes for Q&A. If anyone has any questions, Justin.
So for the client APIs, it's gonna do the controlling of communication between the endorser to the orderer.
It can. So there will be two options. The client SDK can perform all of this dance with transaction endorsement and collecting of all the signatures itself, or it can move this logic to the peer, so it just endorses the transaction, and then peer will do all of these approval processes for it. So there'll be two options to do that.
So a configuration file.
Yeah. It will be configuration for the channel.
Okay.
Yeah.
And then for the
Yeah, please go ahead.
For the channels, you say you can have multiple channels right now, right?
Yeah.
So from a channel perspective, where do you create the channels? Can you create it dynamically, or to predefine the channels upon creation of the chain?
Channel is a chain, and you don't need to create it with the whole network, like right now with the peers, right? You have to predefine the peers in the very beginning. But you, in that sense, you can create them dynamically on the way. And there'll be, like, if you want to isolate all the transactions that will be performed and a number of, and put number of smart contracts into this channel. So that's the thing that you can do dynamically. Yeah.
Great. Time for 2 more questions.
You mentioned that the policy is predefined in the beginning.
You define it for the chain code when you instantiate
For the chain
code.
So can the policy be changed later, or can it be defined for specific contract? I want to use this policy, and for another contract, I want to. Is it possible?
Policies will be contract specific. So when you deploy the contract, you define the policy for it. And then if you need to update it, you will need to redeploy the contract. Okay. The contract redeployment will be a supported feature in the new version. I mean, it's going to be a feature in the new version. Yeah. In version 1. Yeah.
On which blockchain network is it working?
It's Hyperledger Fabric. It's the blockchain network by itself, right? It's an implementation of the blockchain. Like
Processing fees?
No. I mean, the network can define how they want to operate. Do they want to have processing fees or not? And that's the difference with the other networks you probably can think of, like Bitcoin or Ethereum, where you're already restricted with something. I mean, there are pros and cons for all, but here, the idea is that it's a private network where you control the access, who can do what kind of transactions people can perform, and so you don't need. You can relax a little bit the consensus requirements. Like you don't need proof of work. You can use BBFT, which is a kind of relaxed version of consensus, and you don't need the things like paying for transactions in order to stop people from performing too many transactions at the same time. You can do it in different ways because you have access control, and you basically control access to the network and to the transactions they can perform.
Okay, great. If anyone has any other questions, you can perhaps step outside and continue the conversation. Otherwise, thank you very much.
Thank you.